Hi, my name is Royko, and I'm going to interview Heather Lynch. Could you introduce yourself briefly?
Sure. So my name is Heather Lynch. I'm an assistant professor in the Ecology and Evolution department, and my research specialty is quantitative ecology. So I'm interested in mathematical and statistical models for animal populations. But my lab is very much focused on understanding the Antarctic ecosystem, particularly seabirds and penguins that breed in the Antarctic. So much of our work is trying to understand how penguin populations might be changing over time and to what extent that might be due to climate change or human visitation, for example.
Also, since when did you get interested in penguin?
Oh, it's a very good question. My original background is in experimental physics and applied math. So I became interested in very messy, long-term data sets, and in fact my PhD work had nothing to do with penguins at all. It was on forest fires and insect outbreaks, but I happened upon a long-term time series through a project called the Antarctic Site Inventory, which gave me about 15 years worth of data on penguin populations, and this was a really nice opportunity to apply some of the statistical methods that I've been working with and to expand them. So my interest in penguins very much came about through an interest in modeling biological populations and in the mathematics of it more so than the biology of it, which certainly differentiates me from most of the other people studying penguins who came about it by a love of seabirds, or at least a love of birds as opposed to a love of numbers.
We read your paper about the penguin population.
Mm-hmm.
So you went to the Southern Sea, right?
Yes.
So what were the difficulties that you faced while you were in the Southern Sea?
Well, so our field program involves about 5 months of field work in Antarctica every year. So about November through March, my students and I are in the Antarctic, and we reach the Antarctic by vessel, usually leaving from the tip of South America, Argentina, and crossing what's called the Drake Passage, which is this big body of water that separates Antarctica from South America. And about 80% of all the survey work that we do is off commercial cruise vessels. So we're on cruise vessels with passengers that are paying for vacation, and we're sort of along for the ride. And while they're on shore taking pictures of penguins and visiting the Antarctic, we can do biological surveys. So the work that we do on the cruise ships, I have to say, onboard life is very comfortable because we get wonderful food, we have very comfortable cabins, we have hot showers and all of the things that you wouldn't associate with Antarctic life. But for a while, when I first got involved with this project, we had an Antarctic field camp where we were camping in the Antarctic for 6 weeks at a time. We would get dropped off and left, and then picked up 6 weeks later, and we had to bring all of our food, all of our water. We were living out of tents in the Antarctic, and that was much more challenging. So I think among the things that makes that difficult is nearly 24-hour daylight. So it's difficult to sleep comfortably when you have 24-hour daylight, and also just the lack of privacy or personal space when you're working in a field camp like that. That there's nowhere to go, and so everyone has to get along, and there are long hours, and staying sort of upbeat and positive and being a good team member, I think, is much more challenging than the science of it, which is actually not that difficult. It's much more difficult sort of staying happy and cheerful for what can be kind of an emotionally exhausting field season.
So you had a hard time with it?
Well, I would say, there were lots of highs and lows, and the highs definitely outweighed the lows. Among the things that make it wonderful is that the Antarctic is an inherently international place, and some of our best friends in the Antarctic were from the Ukrainian station that was just 6 miles away. But in addition to the Ukrainian station, we regularly interact with people from Chile and Argentina and the UK. There are Polish stations, and there's just dozens and dozens of countries have stations in the Antarctic, and I think that's one of the things that makes it such a wonderful place to be, that you don't have to travel the world, they all come to the Antarctic. So
would you like to go there again?
Well, we go every year. Every year we go. This will be, I think coming up this season will be my 10th year in the Antarctic. I'm not sure exactly when I'll go. I go between the 2 semesters when I have to teach both fall and spring. But I wouldn't miss it. The only year that I've missed going to the Antarctic was when my daughter was born. She was born in November, and there was just no way I was going to go in the field that year. But I went the following year when she was 11 months old. So I wouldn't miss it for anything. It's a lot of fun.
In the paper, you wrote that there are 2 methods to research penguin population. One by the satellites and by the combination of ground counts.
Yeah.
Could you explain more about the ground counts?
Sure. So what we actually do when we're in the field is we literally count every nest or every chick that's at the site. So people often assume that we do a lot of extrapolation, that maybe we count this group over here and we just multiply it by a factor of 8 to make up for the ones we didn't count. But we really do count every single nest. And we have these handheld clickers that you might see going into a concert or going into a sporting event where they count off how many people have entered the stadium. These are exactly the same ones we use. And so everybody has their own strategy. I tend to go from right to left, and you count all the ones you can see, and then you move to the next little clump and you count those. But we'll count thousands and thousands and thousands of penguins in a given landing. We count each little group 3 times to try and get an estimate of our uncertainty. So as long as our 3 counts are within plus or minus 5% of one another, we consider that to be a good estimate of how many penguins are actually in that area. So it's pretty labor intensive. It's not rocket science, but it takes a lot of practice to get good at counting all of those penguins, and in fact, not the animals themselves, but we're counting the nests.
So you literally traveled everywhere where a penguin lives?
So in the field counts, with our project, we reach about 200 different breeding locations over the course of the entire project. So in any given year, we might reach 30 or 40 different places, but it's a different set of places every year. Whereas with satellites, we can count the populations around the entire continent. So our ability to do this by satellites is much greater, and includes areas that we can't even access by boat. So not all of them are counted directly. I would say about a third of all the breeding colonies we can count directly, just using cruise ships.
So I saw some kind of equation by the satellites to count the penguin population.
Yeah.
And it looks like really complicated.
You know, it's actually not. And what makes this work is that penguins pack in a very predictable density. So it's kind of like if you were to put a whole bunch of ping pong balls in a tray and you shake them out, they would have this hexagonal packing density, like a little crystal of tennis balls. And there's only so many you could pack into a particular space. And penguin nests are like that too, because they're very defensive of their nesting territory, and they steal one another's stones. And if they're packed too closely together, then in fact, their stones will be stolen by their neighbors. So they have to be just far enough away that their neighbor can't steal the stones that make up their nest. And so we find that they pack like little ping pong balls across this landscape. And that means that there is if we know what the area is of the colony, we can work out how many penguins were actually in that area, because we know exactly what the density is. And so from satellites, we can see the area of their guano, because they sit there and they're pooping all season long, and their poop sort of, piles up. That's what we see from space. And we can actually draw a little line around their colony boundary, and we can work out exactly how many penguins were in that area. So if penguins did not pack so predictably, the method wouldn't work. And we're only just now getting to the point at which we can count individual penguin heads. The satellites are getting better and better and better. The resolution is getting smaller. And so now we have 31 centimeter resolution imagery from space, which is, I think, just at the point at which we might start to be able to count heads, which is a much more direct method.
This sounds really interesting. So, according to your paper, the population of Adelie penguin has increased by like 1.3 million breeding pairs past 20 years. So even though there are many like climate changes, such as decreasing of sea ice how do you explain the increase of penguin population within 20 years?
Sure, so the changes that we saw were, we estimated, probably equally divided between finding penguins that were probably always there that we didn't know that were there, so just a better methods. And then the other half was probably a genuine growth in the population, that the population probably has genuinely grown over the last 20 years. And there were two hypotheses that we put forward, and we can't prove this at this stage, but there were two possibilities that we came up with to explain this. And one is that with climate change, we know that the glaciers are receding, and as the glaciers recede, the Adelie penguins, they need bare rock to make their nests. And so there's simply more habitat that's being made available to them. If there's a glacier over the rock, then the penguins can't nest there. But as soon as the glacier disappears, there's suddenly more rock for them to nest on. And in some areas, we think they're very limited by how much rock there is. Because even though Antarctica is a huge place, well over 99.9% of the entire coastline is actually not available for penguins. So it seems like they should have plenty of places to breed, but in fact, they have to sort of fight it out for these tiny little outcroppings of rock through the glacier and the snow. And so as the glaciers have retreated, we know that some Adelie populations have grown to sort of track that glacial retreat. One of the other factors that we think is important is that we have a growing toothfish fishery. So on the other side of the continent from where most of our field work is, there is a fishery for toothfish, which is called Chilean sea bass, so it's stuff that you would maybe find in the restaurant. Toothfish compete with penguins for their prey. So they're eating the same foods. And if you remove the toothfish, suddenly there's more prey available for the Adelie penguins. And so it's not a climate change impact, but it's an indirect effect of our toothfish fishery, and something that should concern us. So we have this idea that climate change will have one signature, which is that populations will decline. And in this case, what we have are two probable anthropogenic impacts, one which is climate change and one which is fisheries, both which are having consequences on the ecosystem, but the signature of that is actually an increase in the Adelie population. Which isn't to say that climate change isn't happening, simply that the effect of climate change sometimes is increased populations as opposed to just always leading to a decrease in populations.
So do you expect the penguin population will increase over the time?
It's a great question as to whether or not what the long-term projections might be. I think in the long term, Adelie penguins will probably disappear from the Antarctic Peninsula, which is where we do most of our field work, because the Antarctic Peninsula is much more maritime, it's much warmer than the rest of the continent, and we find this, with climate change, the sub-Antarctic environment is sort of pushing south. So the Antarctic Peninsula is starting to look a little bit more like the sub-Antarctic islands that are out in the Southern Ocean. And so in those areas, it might be very hard for Adelies to persist. But I think around the entire Antarctic continent, I think that some of the changes that we've seen will continue to happen in terms of increased availability of habitat. So we might continue to see for some time increases in Adelie populations elsewhere. And so on net, we're going to find them disappearing from some areas and growing in other areas.
So we searched about penguins, and we saw the pictures and videos about it, and they're really cute. Is that one of your reasons why you're studying the penguins?
Well, it certainly helps fund the research in that there are a lot of people who are very passionate about penguins and very much want to protect penguins, and so that helps fund some of the work that we do. Because a lot of what we do involves making sure that tourism, for example, is sustainable, and that we're not having a negative impact on penguins through visitation. And that's something that conservation organizations are willing to support. But I think what's really remarkable about penguins is that unlike a lot of birds, they're relatively easy to study because they're not cryptic, they're not hard to find, they're large, they're easy to count, they're stationary. And so we think of them as being the canary in the coal mine for climate change. It would be much more direct for us to simply study Antarctic krill, which is the base of the Antarctic food web. It's the animal upon which all the other animals depend. But Antarctic krill are very hard to study. So what we can do instead is study penguins, and penguins are giving us this reflection of what's going on underneath the ocean, whereas the ocean dynamics are very hard to study. Terrestrial seabirds like the penguins are actually relatively easy to study. And And so if we're seeing major shifts in the abundance and distribution of penguins, it's giving us important information about krill, which might be more direct to study krill themselves, but they're hard to find. Whereas we know where to find penguins, by and large.
So I ask every question that we have got. So thank you for having an interview with us.
Oh, you're welcome. And if you've got any other questions, you can always email me.